Now in this video we are looking at scalars and vectors. Okay, so look at this question. Determine the value of a such that vector a equal to this and vector b equal to this are orthogonal. Okay, now how do we solve this? They gave us a vector a to be this 2i hat plus aj hat plus k hat, and b vector b is equal to I hat minus 2j hat minus 2k hat. So they're telling us to find this missing value here if these two vectors are orthogonal. Now, where the answer lies is here. What is an orthogonal vectors? When a vector is said to be orthogonal, now pay attention. Vectors are said, or we can say two vectors are said to be orthogonal if their dot product is 0, and again if the angles, or if the angle between them is 90 degrees. So look at what it means. Since we have vector a and vector b, if their dot product, that is vector a dot vector b, if it is equal to 0, they are orthogonal. Okay, and again if the angle between them angle between vector a and vector b is 90, we now say that they are orthogonal vectors. Now, if vectors are orthogonal, we can also say that they are perpendicular. So orthogonal vectors are perpendicular. So if vector A is perpendicular to vector B, it means that vector A and B are orthogonal vectors. You can see these questions when a vector is said to be perpendicular, or when a vector is said to be what? Orthogonal. So orthogonal vectors are perpendicular vectors, and vectors are said to be orthogonal if the dot product is what? 0, and the angle between them is 90 degrees. So just take note of this important information. So now here they made us to know that they say we should determine the value of a such that vector a is this and vector b is this, and these two vectors are what? Orthogonal. So how do we solve? We know that vectors are orthogonal if their dot product is what? 0. Okay, vectors are orthogonal if their dot product is 0. So it means that vector a dot vector b will be equal to what? 0. So now, did they give us the value of vector a? Yes, this is the value of vector a. So the value of vector a here is what? 2i hat plus aj hat plus k hat dot. Did they give us vector b? Yes, I hat minus 2j hat minus 2k hat. And this is now equal to what? 0, because they told us that vector a and b are what? Orthogonal. So when vectors are orthogonal, it means that their dot product is equal to 0. So how do we carry out dot product? We carry out dot product component-wise, that is component-wise multiplication. And another thing you need to take note of is that if you dot two vectors, you will get a scalar. When you dot two vectors, you get a scalar, and when you cross two vectors, you will get a vector. So the dot product of two vectors will give us a scalar. When we talk about a scalar, we mean numbers like 1, 2, 3, 4, 5, 6, 7, 100, 1 million. So they are just numbers. But when we talk about vector, this is a vector. A vector is a quantity that has how many components? 3 components. Component 1, component 2, component 3, I, J, K. So you can see I, J, K. So when you dot vectors, you get a scalar, that is a number. But when you cross vectors, you end up getting a vector. Take note of all these GSTs I'm talking about here. Okay. So now, dotting this means we are dotting component-wise. 2 will multiply the coefficient of I hat, because this is I hat, and again, This is j hat, j hat, k hat, k hat. So 2 multiplies the coefficient of I hat, then A multiply the coefficient of j hat. You know, this is aj and minus 2j. So we'll multiply them component-wise. So let's go there now. First, the coefficient of I hat here is 2. So I will now say 2 times the coefficient of I hat here is 1, because this is 1j I hat. 2 I hat, 1 I hat. So 2 times 1. Then plus, the next component is aj. So the component there is a from j hat multiplying the value of j hat, that is minus 2, plus the coefficient of k hat here is 1, multiplying the coefficient of k hat here, which is minus 2, and everything is equal to what? 0. Remember, when you find the dot product of two vectors, you get what? A scalar. So let's expand this. 2 times 1 is 2. A times minus 2 is minus 2a. 1 times minus 2 is minus 2. This is equal to 0. Okay, so here is what we have. 2 minus 2. So what we have here is minus 2a plus. So 2 minus 2 is what? 0 is equal to 0. Okay, so minus 2a is equal to 0. So our a will be 0 over minus 2. So 0 over minus 2 give us what? 0. So our a is 0. So it means that when a is 0, these two vectors are what? Orthogonal. So how did I start it? I first put 2 I hats, aj hat, k hat, dot I hat minus 2j hat minus 2k hat. And I know that since they are orthogonal, it means that their dot product is what? 0. And I started 2 times 2 is the coefficient of I hat, 1 is the coefficient of I hat. So 2 times 1, a is the coefficient of j hat, minus 2 is the coefficient of j hat. A times minus 2, 1 is the coefficient of k hat, minus 2 is the coefficient of k hat. 1 times minus 2. Okay, you now collect like terms. 2 times 1 is 2. A times minus 2 is minus 2. A 1 times minus 2 is minus 2, equal to 0. You now do this. 2 minus 2 is 0. So minus 2a, 2 minus 2 is 0, is equal to 0, because this is equal to 0. They are orthogonal. Finding our a is 0 divided by minus 2, which will give us 0. Now look at this next question. A unit vector a equals this. So a unit vector, this is equal to this. Find the value of what? B. So as you can see, this b is missing. So how do I find the value of b? Now, since they made me to know that this is a unit vector, so what are unit vectors? A vector is a unit vector if its magnitude is 1. So now, if the magnitude of a vector is 1, we now say that that vector is a unit vector. So for them to tell me that this is a unit vector, they have indirectly told me the what? Answer. So what I'm going to do now is this. I know that a vector is a unit vector if its magnitude is 1. So how do I find the magnitude of a vector? So if you have a vector, let's say if I have vector a is equal to a1 I hat plus a2 j hat plus a3 k hat. So the magnitude of vector a is nothing but the square root of sums of the squares of each component, a1 squared plus a2 squared plus a3 squared. So when you have a vector, if you want to find the magnitude of that vector, take the square root, then add the squares of each component, a1 squared plus a2 squared plus a3 squared. So look at my vector here. So the vector I have there is equal to 0.2 I hat plus 0.6 j hat plus bk hat. Now they're telling me to find the value of what? B, by telling me that this vector is a unit vector. Since it is a unit vector, it means the magnitude of vector a is now equal to what? 1. So how do I find magnitude of vector a? So magnitude of vector a is equal to square root of, so anytime you're finding magnitude of a vector, take the square root of the sums of the squares of each component. So the first component here is 0.2, I raise it to 2, plus 0.6, I raise it to 2, plus b, I raise it to 2. So first component to power 2, second component to power 2, last component to power 2. Okay, since it is a unit vector, the magnitude is equal to what? 1. So time to get b. So here I have that square root of 0.2 squared plus 0.6 squared plus b squared is equal to 1. So to remove the square root, I square both sides. Square both sides. So let me make a space here. So if I square both sides, I will have 0.2 squared, 0.6 squared plus b squared raised to power 2 is equal to 1 raised to power 2. So this square cancels this square root, such that what I have now is 0.2 squared plus 0.6 squared plus b squared equal to 1 squared. So here 0.2 squared, if you should solve for 0.2 squared, you should get something like 0.4. Let me on my calculator. So we need 0.2 squared plus 0.6 squared plus b squared equal to 1. We need 0.2 squared plus 0.6 squared then equal to 1 squared. We know that 1 squared is already 1. 1 squared is already 1. So doing that, 0.2 squared will give us 0.04 plus 0.6 squared will give us 0.36 plus b squared equal to 1. So after squaring both sides, so the square cancels the square root, then we now take that 0.2 squared, which gave us 0.04, then 0.6 squared, which gave us 0.36, b squared, 1 squared is 1. So collecting like terms, 0.04 plus 0.36 will give us 0.4 plus b squared equal to 1. So b squared will now be equal to 1 minus 0.4. So b squared will now be equal to 1 minus 0.4 will give us 0.6. So our b will be square root of 0.6. So b will now be equal to square root of 0.6 will now give us 0.7745. So b is approximately 0.775. So that's how to do that. Okay, as you can see, they talked about a unit vector. Now I was able to get this because I understand what a unit vector is. A vector is said to be a unit vector if the magnitude of that vector is what? 1. So that's where I started making my judgment. So since the magnitude of this must be 1, since it is unit vector, I can be able to find anything that is missing. Likewise, this, when we solve this, they talk about what? Orthogonal. So I ask myself, what are orthogonal vectors? Vectors are said to be orthogonal if their dot product is what? 0. So how do I get dot product? Multiply component wise. 2 times coefficient of this 1, 8 times coefficient of this minus 2, 1 times coefficient of this minus 2, everything equal to 0. Like that, you now solve below.